dy dx is equal to e to the x over y squared. Multiply both sides by dx, you get dy is equal to e to the x over y squared dx. Multiply both sides by y squared, bring the y's with the y's and the x's with the x's. Anti-deriving both sides, you get 1/3 y cubed is equal to e to the x plus c. Replace in the initial condition, the 1/3 times 1 to the third is equal to e to the 0 plus c. So 1/3 is equal to 1 plus c. Value of c is equal to negative 2/3. So we have 1/3 y to the third is equal to e to the x minus 2/3. Solving for y, multiplying both sides by 3, we have 3 e to the x minus 2. Then taking the cube root of both sides, we have y is equal to the cube root of 3 e to the x minus 2. dy dx is equal to sine of x over cosine of y, multiplying both sides by dx. And then multiplying both sides by the cosine of y, we have cosine of y dy is equal to sine of x dx. Then anti-deriving both sides, antiderivative of cosine of y is negative sine of y. Antiderivative of sine of x is negative cosine of x plus c. Replacing in the initial condition, we have sine of 3 pi over 2 is equal to negative cosine of 0 plus c. Sine of 3 pi over 2 is negative 1, cosine of 0 is 1, so the value of c is equal to 0. So if sine of y is equal to negative cosine of x plus 0, sine of y is equal to negative cosine of x. Solving for y, take the sine inverse of both sides. So y is equal to the sine inverse of the negative cosine of x. The radioactive element decays exponentially proportional to its mass, so y is equal to ce to the kt. The initial condition is 0, time is equal to 0, and we have 10,000 grams of the element. And when time is 5750, there are 5,000 grams of the element. When time is equal to 1,000, the amount of the element is unknown. So y is equal to 1,000, 10,000 e to the kt. Substituting in 5,000 for y and time to be 5750. Solving for k, we have 1/2 is equal to e to the 5,050 k. Take the natural log of both sides. So the value of k is equal to the natural log of 1/2 divided by 5750. So the equation y is equal to 10,000 e to the natural log of 1/2 over 5750 times t. And we're replacing the value of 1,000 in for t to calculate y is equal to 8,864.351 grams. The amount of pollution that we're looking for is increasing at time is equal to 9. We're talking about a rate. The given rate condition was p prime of t is equal to 1 minus 3 e to the negative 0.2 square root of t, replacing in the value of 9 since we're looking for the rate at which we're increasing, which is negative 0.646, which is a negative, which is less than 0. So since p prime of 9 is less than 0 or negative, then the amount of the pollutant is not increasing at time is equal to 9. Looking for the number of gallons of the pollutant to be a minimum. So we want p prime of t is set at equal to 0 to find our critical numbers. Take 1 minus 3 e to the negative 0.2 square root of t, set that equal to 0. Get the value of time is equal to 30.173. To verify that that's going to be a minimum with p prime number line. So the number of gallons of pollutant is at a minimum at time is equal to 30.173 days. Because p prime of t changes from negative to positive, at time is equal to 3.173 days. Part C, we want to know when the lake is going to be safe, which happens when we have 40 gallons or less of the pollutant. So when time was equal to 30.173, which is when the pollutant was at its minimum, did start off with an initial value of 50 gallons of pollutant in the lake, plus the integral from 0 to 30.173 of p prime of t dt. So we have 50 plus the negative 14.896 gallons, which is 35.104. So since 35.104 gallons is less than the 40 gallons, then the lake is safe when the time is equal to 30.173, which is when the number of pollutants is at a minimum. To do a tangent line approximation, we have y minus y sub 1 is equal to m times x minus x sub 1. Y value being p of t, y sub 1 is 50, the initial gallons of pollutant. P prime of 0 is the slope, t for x, and x sub 1 is 0, the initial time. To calculate p prime of 0, we're placing 0 into the p prime of t equation. Get p prime of 0 is equal to negative 2. So p of t is equal to negative 2t plus 50. Since we want to know when the lake is going to become safe, we want that p of t equation, negative 2t plus 50, to be less than or equal to 40. So negative 2t is less than or equal to negative 10. Dividing both sides by the negative 2, time has to be greater than or equal to 5. So when time is equal to 5, the tangent line approximation will predict that the lake is safe.